Okay, this is 12.2. And before we start out, I got to say a big shout out to a couple longtime listeners and uh, and fans. This one goes out to my nephew Landon and my other nephews who chimed in after watching the last one. Appreciate you guys. Love you so much and appreciate you guys being supportive. So we'll start with this. We're going to talk about weathering. And when we talk about weathering, whether it's chemical weathering or mechanical weathering, chemical or physical, mechanical is physical. Anyhow, when we're talking about those things, one of the things that we have to talk about is what else affects the rates of weathering. And a major reason that we see weathering take place is dependent upon by the type of rock. So I'll give you an example. We've spent time doing igneous, sedimentary, and metamorphic rock. And when we talk about igneous rock being the parent rock for all material, and igneous and sedimentary and metamorphic are all on this giant wheel called the rock cycle, breaking down of rock into other forms is a natural process and a very common occurrence. Okay, so then we have to think about what is sedimentary rock? Sedimentary rock is bits and pieces of sediment or bits and pieces of rock. So it makes sense that sedimentary rock, because it's been broken before, probably is the easiest to be broken. And we find that sedimentary rock is the weakest and the fastest to erode. And even if you cause sedimentary rock to go through a metamorphic process, because it was once sedimentary rock, for example, uh, limestone to metamorphose into marble, the marble is still somewhat susceptible to erosion and weathering and is affected by that. So all of a sudden you go, okay, so igneous rock probably is going to be the most impervious or the rock type that is the least susceptible to weathering. Then you think about metamorphic rock being metamorphosed changed. So if it metamorphosed igneous rock, it's going to be really hard. If it metamorphosed sedimentary rock, not so hard. So there's that scale there. And then you get into sedimentary rock and it's going to be the weakest. Now, another thing that we deal with is something we call the amount or time of exposure. Um, the amount of exposure, so if the whole thing is exposed, greater weathering takes place. If the longer or the length of time of exposure, again, the greater the erosion or weathering. So it makes sense when you think about that. Climate. Now, here's the deal. Climate is one of those things that it just makes complete sense when you think about it. So, climate, if it's always dry and it's always hot, not a lot of weathering or erosion, right? Okay, hot, dry, no, virtually no erosion. There could be some weathering due to sand blown or something like that, but it's the least susceptible. Okay. Okay. So then we go varied climate, hot, cold. Hot, cold causes weathering because you're changing the temperature back and forth. Makes sense. Moisture, no moisture, moisture, no moisture, moisture, no moisture. So going back and forth from liquid changes. Freeze thaw changes. Um, super cold or cold, no moisture. So if you think about it, when it's really, really, really cold, you might get some snow. Most of the time, when it's really, really cold, you don't get snow. So you got this cold. If it's super cold, no breakdown, no weathering, no issue. Um, but it's that middle of the road thing, the hot, cold, water, no water, freeze, thaw, going back and forth. It's just this rapid back and forth that causes extreme breakdown. So climate is a big factor. Why do Illinois roads, why are they so bad? I keep coming back to this, right? As they freeze, they crack, they thaw, water fills the crack again, it freezes, expands a little bit more. I've talked about Cleopatra's Needle. Want to bring it up again because I think it makes quite a bit of sense when we talk about it and think about kind of how Cleopatra's Needle. Here's a obelisk from uh, you know 5,000 years ago. And this obelisk is given to New York City in a grand gesture of, hey, we're sisters, and we want to be with you as far as um, in spirit, and you get something like this, right? So all of a sudden you're like, oh, so you've got this Egyptian obelisk that's brought in the 1870s to the United States, and now you can't even read it. In fact, this is kind of interesting. So this is the actual breakdown of what uh, what it said, and it's like Lord of the Vulture, Urasus crowns prolong as to the kingdom, even though the sun in the heavens by Tum, O Lord, on begotten. Right. So somebody took the time to record and write it down. And thank goodness, because it would all be gone. I love this banner name. Crowned Horus, Bull of Victory, son of Kepra. I have this vision in my head. Uh, but thank goodness. And why did it break down? Well, New York, hot, cold, hot, cold, hot, cold, hot, cold, hot, cold. New York, dry, wet, dry, wet, dry, wet, dry, wet, dry, wet. Freeze thaw, freeze thaw, freeze. I mean, it's this rapid change in climate. Now, to be honest with you, pollution in the atmosphere due to carbon dioxide and carbon monoxide, sulfur dioxide, sulfur trioxide, those things going into the atmosphere from burning fossil fuels, those play an effect on it as well. So the more acidic, the breaks down the material as well. This one's interesting. Topography. Topography. The higher up something is, the more effect we have weathering wise. Well, why? Well, it's kind of like jumping out of an airplane with no parachute. It's 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 not the fall that kills you. It's the sudden stop at the end. And so then all of a sudden you go, oh, rocks, freeze thaw, crack, falls off the side, and then what do we have? It breaks on the ground. And so when I think about this, and I think I brought this up some time ago, that here's pictures of us four wheeling, and when we're in Colorado, and you can see that this material has broken off. Well, where did it break off of? It broke off of this cliff. Freeze thaw, crack, drops down as a boulder, hits down below, breaks apart. So now we see this increased amount of this material that we call talus. This talus is broken off this rock face, and as it falls down, it hits down below and cracks. And so topography, the higher up, the more increased the slope. If you're on the flat, you're not going anywhere. Probably not going to have a problem, right? You're just going to sit there here we are. But if you're like this and you're up here, boop, yeah, gravity. It's kind of interesting when we talk about breaking stuff down. If we look at these squares, this is a square that has a length of 2 units. I don't care what it is, by 2 units by 2 units. So it's a cube. How many sides does a cube have? 6 sides. So length times width is 2 times 2, which is 4. It has 6 sides, 4 times 6, which is 24. So we have a surface area, it's 1 cube. We have a surface area of 24 square units. Pretty simple math. If we slice it in half, again, I don't care if this is centimeters or miles. I don't really care. Now we've sliced it in half this way, slice it in half this way, and slice it in half once again, straight down the middle. So we've gone 3 directions with our cuts. Then we say, okay, that means that each cube is now, instead of 2 by 2, it's 1 by 1. Now we have 1 times 1 is 1, times 6 is 6. But how many cubes do we have? 1, 2, 3, 4, 5, 6, 7, 8. What did we do? 24. Now we said 24 and 24 is 48, right? And you guessed it. When we cut it in half again, what do? We double the square units. 48 and 48 is 96. Now all of a sudden you go, oh, we're increasing the surface area. Yeah, more surface area, the more happens. Makes sense. More little cracks and crevices that can take effect. These tombstones, we'll be doing the tombstone project. Be happy the fact that we're not doing it now because it's cold outside. This is a slate headstone. All of the markings are in there because slate is not broken down by acid rain. It's very hard, very little broken down. But marble, and you'll learn this as we do our headstone project, marble is very susceptible to acid. I think I've shown you on tombstones before that when you put the acid on the tombstone, it very quickly eats it away. And so you're going, well, that's really terrible because then these people lose their identity. Yeah, that's exactly right. But the other problem is it's demonstrating that the type of rock here and the type of material. And here's something else that's not even on this. We found that tombstones facing north-south versus tombstones facing east-west, the north-south ones get less breakdown. Why? Well, to be honest with you, what do our weather patterns in the United States do? They go from the west to the east predominantly. And so the north-south ones don't get as much exposure. They get it from the edge, but not in the fronts. So I think that's pretty interesting. So, all right, we're going to go ahead and stop there. Can't say thank you enough for all you guys do. Appreciate you. Make sure that you tell someone how much you care about them. Let them know. And I can't wait to see you guys soon. And thanks so much for everything.